I don't expect you guys to come up with questions, to presuppose what we're going to talk about. But if you do, ask me. Otherwise, you're stuck with the fact that you're going to get dumb examples, which is okay. All right. Okay, so now we're past Tuesday's lecture. I just wanted to give you break and continue. By the way, are again, they're things you never need a break and you never need a continue. Sometimes it makes your code look better if you use them. When you use them judiciously. Don't have 13 breaks and 12 continues scattered over 2 or 3 loops. What it's best to do is you generally use them when you have a long loop, when you have a lot of stuff in the middle, and where you can make a decision at the start of the loop that decides whether you want to do the stuff in the remainder of the loop or not. So generally what it'll be is you'll have a couple of statements doing some tests at the top of the loop. You'll do your break, or you'll do your continue, or you'll do a break or a continue depending on the input. And then you'll have the rest of the processing, and it just gets you around having to have these nested if statements. Right, once you hit the break, you don't actually need the else clause, for example. So anyway, just use them judiciously, but they are out there. Learn how to use them. They will make your life easier. They're never needed. They're often useful. Use them when they make sense. And when they make sense, you'll start understanding as you get used to reading other people's code and what's easier to understand and what's harder to understand. I'm starting to fade out. This isn't good. Somebody must have gone back in time and they're erasing me. My shirt's starting to die. Or maybe they're just erasing cotton. I don't know. All right, so now we're going to start talking about data from files, and we're going to talk about web pages. So far in all of your labs and in all of your homeworks, whenever you've had to get data from a file, we've kind of done that for you. We've given you functions for the Yelp lab. We gave you functions in the homework. I believe this homework, I'm getting 4 and 5 confused, that actually allow you to read the data and get something back in a form that you're ready to process. But the code to do that is, in the end, just code. And it's something that you can actually do yourselves, and will have to at some point in your life probably. So what I want to do today is we're just going to go over a bit of that. We're going to talk about opening, reading, closing, writing files. And then we're going to go into how to get files from across the web. And we've already done this, right? We had we did this with our list of words right in lecture 1. And then these are some more esoteric or introductory kinds of materials to what we're talking about. But parsing is data has a format, and in order to understand the data, you have to be able to pull out the format. So parsing basics, parsing HTML, that's just basically taking the data you get and turning it into something that's actually useful. So we'll kind of go through that. I don't always remember to say this, but this is loosely tied to Chapter 8 of the text, which means that any supporting material will be in Chapter 8, but you probably want to read the notes and watch the lecture for what we're actually going over. We talked about some string operations, and the first thing I want to do is I want to review some string operations that you're going to need. Right, so we're going to start off with we're going to set up a little variable x. See, let me bring that there so I can I can cheat. And we'll pop this into our handy dandy spider. And we're just going to set up x to be this kind of random looking weird kind of string. And you remember that we had this thing called strip, and what strip did was it took whatever you put inside here and it pulled it from this end and this end until it got to a character that wasn't in whatever you put here. So right now I don't have anything there, but let's put in red exclamation point. Right, so now what we're going to do is we're going to look for R's, E's, D's, or exclamation points, and we're going to peel those off until we get to something that isn't an R, an E, a D, or an exclamation point, which is this first. On the left side, it's this first space, and on the right side, it's this last space. Right, and so this is going to return let's go space, let's go red, go. Notice that like a lot of string functions, or like all string functions, right, strings are immutable. It doesn't actually change the string, so X remains the same. So we can use this again, and we can do something like, instead of stripping red, exclamation point, we can strip exclamation point EDR or something like that. Oops. And we're going to get exactly the same thing. So on the strip, this is an important safety thing. On the strip, the order of our characters doesn't matter. If, as it's reading through, if this character appears any place in this string, we remove it from the answer string, right? So it doesn't matter that this said red and we said exclamation point EDR. The R, the E, the D, and the exclamation point are still in this string that you want to strip off, so it's still going to get operated on. And we can do this, similarly. This strip does it from both ends. We can also do it just from the left side with L strip, and just from the right side with R strip. There are a couple other things that we want to keep in mind. This is when you know what you want to strip off. When you don't know what you want to strip off, or maybe you want to strip off all white space, there's another form. So if we do something like this, right, this is just a string. It could just as easily be a variable, right? We could say X equals double quote, space, go space, red, exclamation point, space. So it doesn't matter that this is a literal. It could also be a variable, a string variable. But if we execute the strip on that, what it's going to do is it's going to peel off all of the white space. Now, in this case, the white space is only spaces, but it doesn't have to be only spaces, right? We can throw some random /t's in there, right? Tab characters, some random /n's, throw a /n in here. I'll throw in everybody's favorite /r, right? You guys, a lot of you have seen that on your homework. /r, by the way, just for those of you who haven't read the discussion forum or who haven't run into this problem, when you're doing input on Submiti, depending on whether the input file was written on a Linux machine, or Submiti is a Linux machine, by the way, depending on whether the input file was written on a Linux machine, in which case it's compatible, or a Windows machine, in which case it isn't quite compatible, the end of line character changes. It's normally not a problem, but in some of your homeworks, you're seeing an extra /n/r on the other side of, you're seeing an extra /r when you do a strip or a split. And that's because /r is actually in the file. It doesn't cause any problems. If you do something like, right, strip with no arguments, what you'll get is that's still a white space character. It gets stripped off, right? So we can embed other white space characters other than spaces in the front of our string, and if we're doing strip, it'll take it off. When we start getting too specific, though, we start running into problems. So if now instead of executing this, we say we want to strip off all the /n's because we think that there's only going to be /n's on the end of our strings. When we do that and we have something that's not a /n, it doesn't behave the way we want. Like this didn't modify the string at all because the string had a space there and a /r there, right? So we want to be careful if our goal is to get rid of white space, or we want to get rid of line feeds, we have to be very careful about how we're doing our strip, right? There's a big difference between a string that looks like this and a string that looks like this, right? So that's one of the things you have to be aware of, and this strip actually affects another function we're going to talk about in just a second called a split, right? When you do the strip and you don't specify an argument, it takes off all white space of whatever variety it happens to be, and it works, by the way, for L strip and R strip as well. If you specify it, only the characters you specify get pulled out. So it does make a big difference in the way you go forward, and that is pretty much what we talked about there. So now let's move on. We still have our split. I'm going to reset X to be something different, slightly different. You know, X right now is what? Red, let's go red, go red, go red, red, go, go. We will make it slight, no. Come on, grab the thing I want you to grab. There, we'll make it a little bit longer because we're going to want to do some split functions, right? So some of you have been using splits to kind of break up strings and divide them into, right? A split takes a string and it divides it at the split character into, well, multiple strings. So if you just do split with no arguments, again, that's going to split at any white space. And it's going to do it kind of sane, the way you would expect it to, right? Let's becomes a string, go becomes a string, red exclamation point becomes a string. All of that looks right. Let's split on something else. Let's split on the exclamation point, right? So the split function looks for whatever character you put in here, right? And here it looks for any white space. In this form, it looks for whatever character you put in there. It takes that character out of the input and then divides the string at that point and puts each element, each side into a list. So, right, let's go red. The exclamation point should be there. It's gone. Space, let's go red. Space, let's go red. There's where the exclamation point should be. Space, go red. Space, go red. Space, go red. Space, go red. And then we have Mr. Empty List sitting out there at the end. So that's Mr. Empty Space there. Empty string is kind of the difference here. So let's think about the reverse of the split, which is the join. And the join takes a join character, right? And it takes a string. It takes a list of strings. And what it does is it puts between every two lists of strings, right? So between let's go red, it'll put the exclamation point back in. Then it'll concatenate this string on, exclamation point, concatenate this string on, exclamation point, concatenate this string on, exclamation. And then because there's another element in the string, it'll put an exclamation point and then concatenate on the empty string, which results in nothing, right? So this will completely reconstruct when typed incorrectly. This will completely reconstruct our string X. So this empty list is necessary to finish the reconstruction, right? Without that there, we don't put, we don't put that last exclamation point in here. Let's try something. Y equals X dot split, exclamation point. Right, so Y is our list, and if we do Y dot pop, that should get rid of that empty string on the end, right? And now if we do a join on Y, what we find out is that without that empty string, we don't know to put another exclamation point at the end here. So we lose our exclamation point. So those empty strings are necessary in order to reconstruct the string. And when you use to reconstruct the original string from the split list. So when you use a separation character, the idea is that you can put this back together again with the same or different punctuation. So for example, if RPI is losing, I guess we're not playing hockey this year, I guess, right? We're no longer so excited. Let's go red. Let's go red. Go red. Go red. Or Oops. There we go. So that's kind of the difference between doing a split right? This one is considered to be a split to tokenize things, to break it up into separate words. The idea being that you're not going to put it back together again, or not going to put it back together again in the same way. And something where you're giving it the separation character, the concept is that you may want to put it back together again. So you have to maintain empty lists where you need to maintain some empty lists in order to take care of things, multiple exclamation points or exclamation points at the end. What else do we have here in this one? So where is this really important? Let's take a look at something at the difference here. Let's take a slightly more complicated string. Right now we have lots of white space. Right, we have this white space, we have this white space, we have this white space. Slash n, oops. Slash n is a white space. We have multiple spaces there. We have a slash t, that's a white space. And if we split that on a space, what we're going to find out, and I can't make this long enough to actually show you well, but what we're going to find out is that, well, we're actually maintaining, right? This is where we had the multiple spaces in a row. In order to reconstruct this, to put all the spaces in that we needed, we have to have these empty lists. We had to keep slash n in there because, well, we had a space, we had a slash n, we had another space, so a space will go before and after that. These are the 3 spaces in a row. We need to know to put 3 spaces in a row back. We have our slash t, right? We had a space, a slash t, a space. So that's, if we specify the space, if we split it just on white space and get rid of that argument, right? Provide no arguments to it, it looks completely different, right? We no longer have the slash t in there. We don't have the multiple null or 0 empty strings. We don't have the slash n. So, again, you have to be careful about what you're doing. If you're breaking it at white space for a specific reason, like maybe you want to break at a slash n in order to break it up into lines, right? Then you need the slash n. If you just want to break it at white space to get tokens, like where a token is the actual words, well, then you want to do something with a split here. And by the way, if we start coming in here and doing something like throwing some slash r's in there, like you guys see, right? So we have like a slash n slash r, right? That's what's happening at the end of the lines when you read something that was written with a Windows machine on a Linux box, right? Split with our arguments gets rid of the slash r's, and split with arguments doesn't.
Professor, could you scroll back up to the input 35? I just want to see the difference between that one and what you did for 36.
Sure.
Just so I can see it again.
There you go.
Show up to the input, like what you actually typed in.
I split it with a space in the center.
Oh, okay.
So I split it explicitly on a space instead of allowing the split to split on all white space.
All right, thank you, because I didn't see that, so I was confused on what I was doing.
Yep.
Both. Appreciate it.
So again, you're welcome. So again, the difference is split with both strip and split have different behaviors when they're given with no arguments versus when they're given with an argument. And it's important that you know that, and it's important that you understand it enough that you can come through and kind of figure out, this is what you guys were seeing in a lot of your syllables exercise, was that extra slash r. I guess that's pretty much. One more thing we could do here. Let's go back to, this is breaking it up on the slash n, right? It has the slash r here. It has the slash r here. If you want to get rid of that, one thing you can do is you can do a dot strip, right? If you still want to split on the /n, but you don't want that extra /r or the extra empty list hanging around, you can do something like, do a strip first and then a split on the end. And, you can't, that won't get rid of this one, but it will get rid of that last tag along /r that we would get when we don't do the strip, right? This gets stripped out by, where are we? Okay. Yeah, this gets stripped out when we strip out all of the white space. All right. Okay, so one more thing, and then hopefully we get on to reading files, which is really the exciting part of this lecture, which kind of tells you this is a utility lecture. When you're opening files is the highlight. You don't have very many highlights. Sorry about that.
On the note of reading files, can I ask a question briefly about the lecture exercise?
And wait till we're doing the reading files. Okay? We'll get through the find first. All right, so if we look at X is still let's go red, etc. Just to remind you that there's this find function, and find will look for a substring in a string, so we can do x.find, I don't know, red. And by the way, all of these are case sensitive, so x.find red gives us 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, and then it gets us to the R, which is 9, right? So it'll find the substring red. It tells us that the substring red starts at 9. If we do it with a capital R, well, there's no capital R anywhere in this sentence, in this paragraph, whatever you want to call this. So it doesn't actually find it. This is all case sensitive. It is also order sensitive. So if we do something like EDR instead of RED, it also won't find that. It's looking for the exact substring. Question comes up, how do you walk through, if this always just finds the first occurrence, how do you walk through? Well, you can give it optional arguments. So if we know that we're at 9 and we want to continue searching past that, we take the 9, which is where it found it, we advance it by 1, and now we start looking at position 10. That tells us the next one's at 23. That would be this one. And we can do 24 in here, and then it'll tell us the next one's at 31, which would be this one. And we could put 32 in here, and that'll move us past to 39, which is this last one. And if we put in 40, what we'll find out is that there's no more, so it'll return a -1. Okay, so we can give it one parameter, which is just the string we're looking for, and it'll return the first one. We can give it 2 parameters, string we're looking for, and the start position. And we can also give it 3 parameters where we give it the string we're looking for, a starting position, and then an ending position. Don't go past 20. Oh, let's not go past 24, for example. 23, for example, right? Right. This should return 23. This says the string has to end before string 23. So it returns a -1, right? Because this red starts, starts at position 23, 24, 25. We won't actually find this, I think, until we do 26. Right, now we've got enough letters in there. Right, so it's basically taken out, it's searching from here to here at this point. All right, and if we go on past that, nothing's going to change unless we change the starting value. Okay, so this allows us to provide a starting point, a search string, a starting point, and an end point. The starting point and the end point are optional. If you don't want to find it, if you don't need to know the position, you just need to know if it's there, you can just ask the question, is red in X? And it'll say yes, or it'll say no. Okay, so if you just need to know, is it there, as opposed to having to know its position, you can just use the if function, or the in function, and that'll work in that generates a Boolean, so that'll work in an if statement as well, or a while statement. If red in X Must hit return twice. Print. Huzzah. Okay. And again, that'll work in a for loop as well. Or I'm sorry, in a while loop as well. All right. Okay, so we got about half an hour to go. That's probably pretty good. We're probably in decent shape right now. Yeah, we're not in horrible shape. The parsing is not really a big test item, so we're probably pretty good. Okay, so